In this video, we're going to look at measuring two-dimensional spaces. With two-dimensional spaces, there are two things we might be interested in measuring. One is perimeter, and the other is area. This comes from section 10.3 in your book. Okay, so let's start with perimeter. Perimeter simply means distance around. Literally translated, it means to measure around. Meter translates to measure, and peri means around. So it means to measure around. We're going to find the perimeter for some different figures. The first one being a rectangle. Okay, so here is our rectangle. Now, it is true that we can have formulas for perimeter. Formulas are just shortcuts, and sometimes those shortcuts or formulas are helpful, and sometimes they just muddy the waters. To be quite honest, when it comes to perimeter, I find that formulas aren't the most useful thing because they tend to fall apart depending on which figure you're dealing with and certain instances. So really, what I would like you to remember is that perimeter simply means distance around. And however you go about finding that distance, be it the long way or shortcutting it somehow, that's fine. So if we want to find the distance around the rectangle, it stands to reason we're just going to add up all the side lengths. So the bottom is 7 inches, the right side is 4 inches. Now when I get to the top is not labeled, not directly, but that marking on there indicates it's the same as the bottom. So I know that it's 7 inches. And the markings on the left side show that it is the same as the right side, which is also 4 inches. When I go and add that up, 7 plus 4 plus 7 plus 4 is 22. The units, when we're dealing with perimeter, we're just adding up a bunch of inches, so it's inches. Now, could we have shortcutted this process and taken twice the length plus twice the width, which is the standard formula that many of you may have encountered when it comes to finding perimeter of a rectangle? Absolutely. Or could you have taken the length plus the width and doubled it? Absolutely. That's another way of expressing the formula. But that formula only works for a rectangle. What happens when we get to, say, a triangle? Such as this. Now we have no choice but to remember the concept of perimeter as being the distance around, and all we can do is add up the sides. So that's why I say sometimes formulas just muddy the waters, and as long as you know the concept of perimeter as being the distance around, in the case of the rectangle, you don't necessarily need a separate formula for finding perimeter. There is a formula on your formula sheet. In class, we'll be reviewing these formulas just to show you where they're at. But again, just remember perimeter is distance around. So back to the triangle. In this triangle, we're just going to simply add up the 5, the 6, and the 8, and we get 19. Now you'll notice in this problem, I didn't put the units in my work, but I am a bit of a stickler about units when it comes to the final answer. I'm not a stickler about much, but units is one thing that are very important. So whether you put them in your work or not is no big deal. Just make sure you put the correct units in the final answer. So in this case, again, we are adding up just a bunch of centimeters, and so our final answer is in centimeters, 19 centimeters to be exact. Another example, let's say we want to find the perimeter of this figure. Okay. This is a square. Some of you may have been taught the formula that the perimeter of a square is 4 times s, where s is the length of the side. Okay, well now you've got a perimeter formula for rectangle, a perimeter formula for square. Really completely unnecessary, because as long as you remember perimeter is just distance around, then it is very easy to go ahead and just add up the 4 side lengths, in which case we get 8 inches. Now if you happen to notice that, hey, these markings indicate that I have 4 sides all the same and they're all 2, and you just want to go 4 times 2, then that's great. You just shortcutted that addition process, and that is totally fine. Either way, we're going to end up with our 8 inches for our perimeter. Let's look at another example of finding perimeter. One last example. Okay. So here is my right triangle. It's meant to be a right triangle. My hand got a little shaky there. Perimeter. We know perimeter is distance around. So we go to add up the side lengths just like before. And when we get to that third side length, we see we do not have it. Guess that means we can't do the problem, right? Oh no. Perhaps you're thinking about that theorem that relates the 3 sides in a right triangle. You may not remember what it's called, but that was the Pythagorean theorem. What the Pythagorean theorem says is that when we take, so first let me draw a right triangle and label the parts for you. Okay. Every right triangle has 3 sides, as any triangle does. 2 of those sides are called the legs. The legs are always the 2 sides that form the 90-degree angle. The third side, or the side opposite the 90-degree angle, is what we call the hypotenuse. What the Pythagorean theorem says, and as you may have learned it, a squared plus b squared equals c squared. I prefer to remember it and talk about it as it actually applies to the triangle, which is leg squared plus leg squared equals hypotenuse squared. In other words, if we drew a square off the leg, the area of that square plus the area of the square off the other leg equals the area of the square off of the hypotenuse. The reason I prefer leg squared plus leg squared equals hypotenuse is because what happens if I change the letters? For example, in our above example, the hypotenuse may be labeled x. Well, now some people might get confused by the a squared, b squared, and c squared. Okay, so back up to our example. In order to find the perimeter, we need to find that missing side length. So by applying the Pythagorean theorem, and I'll just rewrite it up here, one leg is 4, the other leg is 3, and the hypotenuse, you can call it any letter you like. If you like c, go ahead, I'll just use x. So we need to clean up the left-hand side. 4 squared is 16, 3 squared is 9, and that's equal to x squared. So x squared is 25. We are not interested in x squared, though. We are interested in x itself. To undo squaring, we do the inverse operation, which you may remember is square rooting. In other words, we're asking what number times itself is 25, and we see that it is 5. Now, even after all of that work, we are not done. I know it might feel like, oh, I found my answer, I'm done, but go back and look at what the question was asking. It was asking us to find perimeter. So we need to finish adding up all the side lengths. The perimeter here then is 12, and remember, perimeter is a linear measurement. We're just adding up a bunch of inches, and so there we have that. The Pythagorean theorem can also be found on the front page of your formula packet. So you can look there to find that formula that will be available to you. You just need to know how to use it. In the next video, we're going to look at finding area of figures.